me salió sí, yo diría que si no, van empujando con y quieren abrirla. Entiendo esto, pero también hay que ver un poco de expresión.
Hay que no recognize.
Bueno, sí, pero ha cambiado de evento. Es un problema de que no van a conseguir los objetivos para el evento si hacen esto. ¿Qué te lo vas a salir contento si los mentores no llegan? Llegan mentores, pero no son expertos.
No vamos entrando ya, que casi que sí.
Hombre, mira, pregúntame si
¿Queréis que os coja algo?
¿Quiero unos yogures?
Sí, me puedes coger para ayudar.
Think of a new way of interacting with information and try to implement it, prototype it, solve some of the hard problems, but mostly evaluate whether that style of interaction could be could offer a more seamless experience and a more sort of usable experience for using information. So one of these projects, but I'll talk about multiple, but the one that is probably the most known is a device that we came up with in 2009 called the Sixth Sense, and it consists of a small projector, a pico projector, and a camera. And the camera can basically track the user's hands, and it can also recognize some gestures and can actually recognize some of the objects that the user may be holding, and the projector actually projects information onto either the hands or the objects that the person holds, and it doesn't just project information, it allows the user to interact with that information. So for example here, if you pick up a book, the user has told the system that every time a book is recognized, he wants to see the Amazon rating for that book. Or you can see maybe audio. Can we have the audio? I think the audio is not on. Is the audio on for the video? Yeah. Sorry. Maybe you'll hear it now. So basically, you can get audio as well as visual augmentations of whatever you're holding in your hand. So when you pick up the newspaper, you can see the latest weather report. When you pick up a boarding pass, the system can tell you that your gate has been changed, etc. You could potentially even show projected onto other people what their particular interests are and so on. That one is a little bit controversial, but so the whole idea here really is that you can really sort of integrate the digital world and the physical world in one experience, and it becomes one and the same experience. So you can augment paper, just use any piece of paper as an interface basically, maybe watch a video game on a piece of paper, or use a piece of paper as your computer, and so on. So that was the whole vision of the system. So here,
good afternoon.
We're just
My
watching
name
a
is
little
Russell,
video.
and I am a wilderness explorer in Tribe 54.
You can play a video game where the way you hold the piece of paper determines the steering of the car, and so on. So we used this same device with the projector and the camera to allow a lay person, a person who's not experienced at all in this case in fixing dishwashers, that person can get instructions from a remote expert who sees what this lay person in her apartment is seeing. So the remote person can draw on top of physical objects in front, like the dishwasher here, and give instructions on how to fix the dishwasher remotely. So we think that this technology also has a lot of potential for changing the whole way that companies service equipment and fix equipment that is broken and so on. Now, I mentioned that we're really exploring many things in parallel, and I'm sure many of you or have heard about Google Glass. Google Glass actually, initially the predecessor of Google Glass was invented also at the Media Laboratory, and in fact the team at Google that is building Google Glass and designing the whole experience is all Media Lab, or most of them are Media Lab people, and the person in charge of it. One of my students also in '98 effectively had Google Glass, or it was a little bit of a bigger design, and he had a whole backpack or sort of a messenger bag with a computer and batteries, and it was actually fairly complicated to do that at that time. But basically, already back then, we were looking again at the same idea of how a computer can be more active in offering information that can be useful. How can a computer be almost an extension of your own mind? And it's specifically what Bradley Rhodes looked at was how a computer can be like an external, basically. A lot of what we try to do in our work, I work, by the way, not just with computer science people and electrical engineers, but we also have a lot of designers in our lab. And so we were thinking about sort of how we could naturally extend and make use of what people already do. And so, of course, one thing people do is they point at things, and you ask a question like, what is that sign, or where is that juice from, or whose juice is this, and so on. So we thought it would be useful to build a ring that has a camera on it, and so you can basically speak to the computer, or to your phone, rather, and take a picture at the same time of something and ask the computer a question about something in your environment. So it's again illustrating how we want the computers that we use and the smartphones that we use and so on to be more aware of what is around us, the users. Initially, actually, we developed this ring for blind people to give blind people an opportunity to sort of see some of and perceive some of their environment. So some of the types of, they're really apps kind of that we built were an app to recognize prices and extract the dollar value of a price tag, or an app to recognize a dollar bill, and so on. And the nice thing is that all of these apps can just be invoked by pointing and saying like currency or color or price, and the system then runs the app basically and speaks the answer. I have a video of a very early prototype. You'll see the later prototype next. But so you can just, you don't have to get your phone out of your pocket. Ideally, this would be a lot smaller, and you can just sort of point at things, ask a question, and get answers like what is the value of this dollar bill, and so on. Sorry, the sound is a little bit quiet. I'll turn it up. So the blind person can point it at a price tag, and then take a picture.
Tag 1 selected.
And then it tells, it extracts the price information.
$27.
So we also since then realized that this would be very useful to have for sighted people. Imagine going, like I was sightseeing in Barcelona, I could just point at things and ask like, who's that in that sculpture, or who built that building, and so on. So it's, we're already getting more and more used to talking to our phones with Siri, for example. But I think that talking or communication between people doesn't just involve voice, it's also gestures and pointing, and the ring can pick up a lot of that and really offer the user a lot more. We recently developed an application for kids where you can take a picture of your surroundings. It extracts the edges, and then you can color the edge drawing using some colors that you find all around you. So you can first take a picture of the angry bird, for example, and it finds the lines. It's hard to see with the light, but then you can take colors from plums and bananas and pears and or textures from trees and so on, and you can use those to then draw the drawing that you are making. So again, it's making more of a link between the digital world and the physical world around us, and which is really the common theme in all of our work. We also built a music reading app so that somebody can learn to read music just by pointing at some paper with the ring using the music reading app, and it can either sing the notes for you or read them and tell you what they are and so on. In another project, another big project in the group which is related to Sixth Sense, is one where we are trying to make a light bulb, a light bulb that is a computer, a self-contained augmented reality system. The system is called Luminar, and basically it is about the size of a big light bulb. It again includes a pico projector, a depth camera, and some other sensors. This is a version from 2012, so it's still a little bit heavy. We had to reinforce the lamp, otherwise it goes bang. But so the idea is that you buy one in the store, you screw it in any spotlight or wherever, and and then you have a projected basically gestural interface wherever you need it. You can also put it on the wall and so on, and it has the Wi-Fi connection, the processing, everything is on board. So it's really a computer in the form of a light bulb. And so the benefits are that it disappears. You can turn it off when you don't need it. You can use it in a messy situation, like in a kitchen or something. And it's more than having touch screens everywhere, because the system can actually recognize potentially physical objects that are there, like the bottle of liquid and so on, and give you information related to physical objects. So it's more than a touch screen. It can you can interact with physical as well as digital objects. So we've actually used this together with Best Buy to make a store, sort of our concept store, where you can buy a camera, and whenever you pick up a camera, it notices that you picked it up. It gives you information about that camera. If you put two cameras next to each other, it tells you what the differences are. You can get reviews, etc. And all of that is just done with a spotlight, the sort of an intelligent spotlight. And they have just recently installed some of our bulbs. It's a bigger version, actually, than the light bulb sized one. But basically, the augmented reality system can see what that person is doing, who's like building a table, actually, and can give him instructions, can say, no, the table is too short, too long, you forgot to include the bag of screws, or you didn't do this right, or so it can actually see, give instructions, teach the person how to make a table, but it can also capture information, then transfer that or show that to another person who's trying to build that table and learning about how to do it. And so we think that in addition to sort of having a lot of applications in the home, that this kind of augmented reality system, there are a lot of commercial applications actually in business and specifically in manufacturing. Another project related actually to some of the work that David is doing here at La Salle is this project where we are trying to extend sort of what is possible with augmented reality technology. In this case, it's just a handheld device, an iPad, which looks at the world and which can augment information about the objects that are in front of you, or show you information about them. But the way in which we are going further is that in this system you can actually change how the real object behaves with the augmented reality interface. So it's sort of a system for basically programming the behavior of physical objects around you, and I'll show you the video which will explain.
Touch devices provide us with a flexible graphical user interface that lets us share and interact with apps and other people. However, a graphical user interface needs our full visual attention. A tangible interface like a light switch, in contrast, can be operated just by muscle memory and the tactile feedback. Smarter objects can combine the tangible interfaces with the flexibility of graphical user interfaces using augmented reality image recognition. The smart device only requires a processor and a Wi-Fi connection to a server that binds the tangible interface with the actions of a graphical user interface. Smarter objects can enhance the concept of a traditional radio. Here we have a radio with a volume and a tuning knob. But we expect more. Nowadays we expect a rich media player. Therefore, this radio has a second graphical interface layer, which let us access all the functionalities we expect from a modern digital radio. Since the graphical layer is tied to the tangible interface, all changes from one are reflected on the other. Once we want to change a tuning spot, we select the song we want to place and drop it on the spot. We have now reprogrammed the radio, and we can use our new selection with a tangible interface. The interface can provide online radios and music services. The tuning knob could include favorite playlists and even alarm events. Once programmed, the device can be operated without a screen. If we want to listen to a song with a better speaker, we can just draw a virtual line from the radio to the speaker, and those devices become instantly connected. Tap the line again to disconnect. This separation of interactions to tangible and graphical interfaces is effective, because graphical user interfaces provide better understanding and modification of programming systems. Once a system is programmed, a user wants to operate it. The operation part can be performed better and intuitively with tangible interfaces. The concept can also be applied on a door opening system whereby a virtual access system grants access to the door. Or enhancing a simple light switch whereby the light switch only triggers on and off, but the graphical user interfaces changes the light color. We envision that the virtual interaction layer supports all interfaces and interaction one can perform at home, garden, or at work.
So yeah, there's a real tendency to, or a very strong interest in making the objects around us smart and internet enabled and so on. But the problem is that we don't want to have a little interface and a little screen for every object, like a thermostat or the light switches in the room and so on. So what we did here is that we have a regular objects with regular buttons and knobs and so on, but then the interface is basically virtual, and you can reprogram or change the meaning of the buttons and the settings of the buttons and what the knobs do using the virtual interface. And you can really program interactions between different objects in a room, or even between digital events and physical events and so on. You can say, every time I get an email or every time I have two remote users can inhabit that world.
Hi, my name is Seth Hunter from the MIT Media Lab. What you just saw is a creative telepresence system called Wazam. Wazam is like Skype plus Connect plus your imagination. Plug the Connect into your PC, connect your PC to the TV, and Wazam, you can connect to other people in your network. In Wazam, what you see is what I see. The magic of Wazam is that we can do things together in the same space. I asked Chris and Brendan from Boston Improv to demonstrate some of the possibilities.
That's the
Brendan, I
media
can't
lab
figure out how to
building.
roll my R in French. Can you help me?
Yeah, so it's like that in the back of your throat. No.
Oh, somebody called the police. Call the police.
Somebody call the police.
They're just gonna leave it?
Oh, somebody do something.
No.
Let all the strings go open on your left hand.
Okay.
And
just strum.
Just strum. Wow, look at them go, man. These guys are some of the fastest Paralympic runners in the world. In fact, they are the fastest. So, what do you think? You wanna sublet?
You know, I'm actually gonna look around a little bit. I don't think I'm interested in this place. Thanks.
This place is amazing.
I'm not saying it's not. I'm just saying I don't know if it's for me, Chris.
What makes Wazam unique is that it allows you to connect with others in more creative and meaningful ways. You can use puppets to improvise and tell stories. You can customize yourself and the environment. You can use gestures to transform yourself. We're just beginning to explore the possibilities of what we could do with this platform. What would you do with Wazam? Tell us at www.wazam.com.
So yeah, we're looking for more collaborators on that one if other people want to try using this at a distance. Some of our other projects, we've done a lot also with exploring sort of different form factors for computers that are easier to manipulate, because a lot of what we do with data is that we want to organize it or sort it or whatever, and well, now we can use a touch screen, but often we're also using the mouse, so you're trying to like sort all your pictures by going like this, or instead of just being able to touch the pictures and move them around and sort them in different buckets. So we thought, and this was David Merrill's work in my group, what if instead of one big screen, we have many little screens so that you can actually manipulate your data really with your hands and sort and organize things. Like, for example, at the bottom is like some like process, definition of a process for a company, business process, and you can just move things around and change this with your hands. This, I particularly like this example actually, where kids can basically play with numbers and arithmetic just by moving the different objects around, and these little cubes have recognize some gestures as well, so you can change like a plus into a minus and so on, right there. They talk to their neighbors and so on. So we've developed a whole set of applications basically where people can use, sort of manipulate their data just with their hands, as opposed to having to do it in an indirect way via a computer mouse. And we've done things like video editing with this, using Photoshop and different filters and so on. There's a lot of things we do that naturally sort of translate to this environment. These days, the student who did that PhD started a company, so you can actually buy these online from the company Siftio. Hasbro, the toy manufacturer, it was a sponsor of the Media Lab. They also made a commercial product based on our invention that you can buy in the stores. A related project actually done by two people from La Salle is to take this to 3 dimensions. So we basically have been building these display cubes, cubes that have 6 displays, so that you can see the projections from all different sides, or maybe can even look inside of Paul's brain here and so on. So the idea is to really have something like Lego blocks, but that have videos basically on all sides, so that you can maybe stack things and build, maybe for the architecture people here, build different models. So it's really like more flexible Lego blocks basically, and that also eventually will be able to know what who their neighbors are and how they are being manipulated and so on. I think computer interaction are on that shelf and so on, and my papers are over there and my files over there. But we're increasingly living in this world where everything is digitized. So all our books, all our files, all our information, it's all basically, we have to access it via this one screen, sort of, and we're no longer taking advantage of the fact that we are people, and that we sort of don't just see like this, but that we can feel things, and we can experience the whole world around us and so on. And so I think that this vision is not at all exciting, and it's really frustrating because it's hard to remember where things are in your computer, and you don't get a sense of sort of where the stuff is, and you don't know you don't have a good feeling of what is going on in the online world. Personally, I find it extremely frustrating. So one small project that we have done to sort of think about this is to build these little screens again, sort of like the siftables or like the display cubes. They're basically little screens that we call cloud drops, because they are kind of like a drop of information from the cloud, the information cloud. A drop of information that stays updated all the time and can keep you informed about something that you care about. So for example, you have many Facebook friends or whatever, and yeah, you can go to Facebook maybe and see what's going on with them. But some people you would want to have a special little display for, because you want to know where your girlfriend is or something at all times, and whether she's called you or stuff like that. So we have been using these little displays that are Wi-Fi enabled. They're basically built on top of the Wim watch, which unfortunately is no longer available, and Android device that is a watch that is reprogrammable. But so you can basically, the idea is that you have a whole bunch of these, and they're kind of like like the sticky notes, except that they're digital and their information can be updated all the time. So for example, we also augmented them by putting a camera on the back, and you can take something like a bus schedule and take a picture with the camera on the back of the cloud drop of the visual tag, and then it knows that it's associated with that paper document, and it will tell you when the next bus is coming. So next bus in 10 minutes, 9 minutes, etc. So it stays updated all the time. So it's a dedicated little display for important information. I am always late, so I want one at my door that says "will be back at," but then I can update it from my phone so that I can correct it that I'm actually going to be there at 4:05 or 4:10. So we'll see a little video of how you can easily associate it with information on the web, so with your inbox, with eBay, with email and so on, and the little displays are updated so that your inbox will show you how many messages you have. That little display shows that. So like here, for example, if you delete one, or your to-do list can be shown on one of them. And you can also do some simple interactions actually as well with the little displays. Sorry, it's a little bit hard to see there. You can put a bunch of them together. we basically have technology to let them talk to each other, and then you can sort of use several of them to attract the user's attention and so on. So we use them for keeping track of the online status of people, and you can do some simple reading of messages and so on right there on the device. So it's staying in touch with another person, getting the attention of another remote person, and so on. So you have eBay, you can see what an item is valued at on eBay that you've been following. And so you can associate them with physical documents, like I said, like the bus schedule and so on, by taking a picture of the tag, and then it knows which document it's associated with. But so right now they're still fairly expensive, but our idea is that these would be as sort of disposable, almost like as sticky notes, so that, or reusable at least, recyclable, so that you have a whole bunch of them, and whenever you need to keep track of something, you just use one of these to keep track of some information that is changing. And then when you no longer need to keep track of that, you recycle it and use it for a different purpose. So in summary, I think that the devices and the interfaces that we are using today, the way we are interacting with smartphones, laptops, computers, is really lacking. And I mean, we're increasingly using all this technology all the time, so increasingly we're all just looking at a little screen wherever we are, rather than sort of enjoying the whole beautiful environment around you, and being able to really make use of information and services while you use all your senses and sort of perceive everything around you. So I think increasingly tomorrow, that we will have other form factors for working with information, form factors that are more of a natural extension of people and the way we do things, and devices that really are a lot more proactive in giving us information that may be useful to whatever we're doing right now.